Welcome to another tutorial of ANSYS 2018. In this video we will gonna see that how we analyze a truss in ANSYS APDL 2018. You can use this guide for any of the versions of ANSYS, but I will be restricting myself to the ANSYS 2018. So for the doing the analysis, first of all you would open your ANSYS APDL. I have opened my ANSYS APDL. So first of all you would go and save your file and your desired directory and change the file name to your desired name. After that, the first step you have to do is to select your structure analysis type. I would be going with the structure analysis, and after that I will be going to the preprocessor. Then for the truss element I would be defining the element type, and for the truss we will be using the element link 180. So basically the link 180 is the element which is one dimensional, meaning to say that it is as simple as straight line or element between two nodes in one direction. So as we know that in case of trusses only axial forces are the main concern, shear forces and bending moments are of negligible. So we will be using the link 180 element. We can also use the beam elements, but in that case we will be having some very much complexity in the total stiffness matrix. So in case of link 180 all the rotations are zero, so we only have axial forces, and all the y components of the forces are also zero, so we get a simplified calculation in while using link 180 as a element type for the truss analysis. So after deciding the element type, I would be going to the sections, and here I will be defining my element area. So I would be going here I will be writing the ID for the element, and I will be going the area with the 1. So I will be using you can use any of units. It can be 1 meter square, it can be 1 millimeter square. You have to be consistent with your units. So after deciding the area, now I will be going to define my truss element properties. So I will be going to material models, and here I will be going to the linear structure, and for the modulus of elasticity I will be also considering it to be 1 and Poisson's ratio as 0.3 for this problem. You can use 0.2 as well, 0.15 as well, but I will be going with the typical value. Second, I will be defining the density. So for the density I am considering a density of 2000 kg per meter cube. So I will simply write the value of 2000, and I have defined my material models. One is the density and one is the linear isotropic. So after deciding the material properties and the element types and deciding the section, now I will be modeling. So we will be basically using this truss element. So what I have to need, I need 4 nodes. So first of all I will go and mark my 4 nodes. So I will go to modeling, create, and after that I will go to the nodes. And the nodes I will be going to the active coordinate system. This will be my first node, and my first node will be the origin. So I will simply write 0 0 for each. So my first node has been created. Now I will be creating my second node. So if I see that this element is my first node, that now if I see my second node, that it is a distance in 3 times of L in minus direction and 4 times vertical. So what I will be doing, I will changing the x to -3 and the y to 4, and that will be remain as 0 because we are working in 2D. So after that, if I see my third node, then in case of third node, what I am having my x as 0 and y as 4, and in the case of fourth node, my x as 4 and y as 4. So I will be doing the x equal to 0 and my y value will be same. After that, for fourth node I will be doing x equal to 4. I will simply press OK. So we have defined the nodes. I will take a zoom out, and you can see that we have defined the nodes. Now after defining the nodes, we will be drawing the elements. So we will be going to the model, create, and elements, and in the elements we will be going to the auto numbered and through nodes. Okay, now I will be selecting this element and this. So my first element is done. Now we will be selecting this and this. Now my second element and my third element. So these are my elements. for the truss. After that, if you see that what we have basically a hinge support, meaning restriction in x and y direction, but we can consider it as a fixed support because we are working in 2D, so that will be automatically restricted, but so we can consider it as a fixed support as well. And here we are seeing that there is no support, instead there is a forces have been applied. So what we do, we will simply go here, and for the node 1, now I will be closing the modeling and I will be going to the loads. In the loads, I will go to the defined loads. In the defined loads, first of all, I will be applying the force. So for defining the force, I will be going to apply structure and the force. In the force, I will be applying the node at the node. So I will be taking this node and I will be considering this and applying a force of 1 in x direction, and also considering this node applying a force of y in upper direction as well. Okay, so after application of force, I would be applying the force at these. So I will be going to the displacement on the nodes. I will select the box and select all these nodes and apply. I can consider all degrees of freedom because I said that it is a hinge support, and in case of 2D we can consider a hinge support as a fixed support. So I will be taking it 0. So now you can see that I have defined my elements, I have defined my loads, I have defined my supports as well. So you can see that this was our truss and I have defined its geometry. Now what I will be doing, since I have applied the load, so I will be going to the solution, and for the current problem I will be not changing any of the settings in the solution, but in the further problems we will be changing some solution setting to see that what it have. I will simply select on solve and I will close it and I simply press OK, and you can see that it has shown that solution is done. Now for seeing the results, what I will be going to general post processing. In the general post processing I will be going to the list results, and in the list results let's see the x component of the stresses. So I can see the displacement as well, that how much it has displayed. So I will be going to the x component, and you can see that at the node 1 it has displayed 6.3415 in the x direction. And in case of y, since in node 1 we have applied the force at the x and as y, so at the y direction it has been displayed 2.2476. okay, so these were the results. Some of the, also if we wanted to find out the reactions, we can find by clicking on the reaction solution and selecting all the items and simply applying. So these are all the reactions at the different nodes I am having, node 2, 3, 4. Since I applied the sports only at the nodes, so these are the different reactions. That will be 0, obviously 0, and the total value is -1 and -1, which I have applied the force. You can I have applied the force -1 in the x direction and -1 force in the y direction. So you can see that the total reactions are coming out to be -1 and -1. So this was the analysis of a simply truss problem in ANSYS APDL. Hope you would have liked the video. If you have any concerns, you can comment below. I will surely try to answer it as soon as possible.